the recording, and Chakri, when you're ready. Everybody, we will be recording. Can we share the presentation, Carlos, with the community? Is that okay? After the event? Yeah.
Yeah,
okay.
Just to let me know how, like, send the,
just
put in the meetup.
Yeah, yeah, whatever you'd like to do, just send it to me and we'll have it in the follow-up email and all of that.
Sounds great.
Okay, cool. So we are recording. Chakri, take it away when you're ready.
All right, thanks, Josh. Hello, everybody. Welcome to another Cloud Native Meetup. We have two awesome guests today, Adolfo and Carlos, to discuss about software supply chain security. So Adolfo, just to give some introductions, Adolfo Garcia, he works with ChainGuard, and he's one of the tech leads for SIG release as well. So if you're seeing your Kubernetes releases delayed, and it should be one of the reasons, probably, right? Anyway, so we are also joined by Carlos Tado. He works with Mattermost, and he's into the CI/CD cloud native space, and as well as very well versed with continuous integration and continuous delivery space. And they will be talking us through the software supply chain security in terms of securing the cloud native infrastructure in general. So without further delay, Adolfo, take it away.
Okay, I hope everybody can see the slides, right?
Yeah.
Okay, let's get started. Hello, as Chakri mentioned, like, my name is Carlos. I was doing the transition while we set up in the talk. I'm not working anymore for Mattermost. I'm working at ChainGuard as well. And also, and also I am tech lead also in the SIG release in the Kubernetes space as well, and contribute for other projects as well. Our talk today, we're gonna talk a little bit about the supply chain. This we was wondering, like, there's a lot of people that this is a hot topic in the nowadays, and but there is a lot of people that doesn't know where to start and what is the first steps, right, to achieve a more secure supply chain for your open source project, or for even for your closed source project in your company. The idea of this talk is we're going to talk a little bit about the supply chain stuff, like on the market, and then we're going to talk about how to sign images or artifacts, the current, like let's say the old school, and the new way we are introducing. And then Adolfo going to talk about the SBOMs, the software bill of materials. And then we're going to do a full demo, like integrating the signing, like building the image, integrating the signing, plus attaching the SBOMs. And then later on, we can verify those things. As I mentioned, like before, like everything is getting like a big traction, and there's a lot of corruptions, or like dependency confusion, type squashing, malicious code injection in a lot of open source projects. And this is increasing like over the year. Like we have this Sonotype report from last year. It increased like this huge amount of stuff. And if you think like, it's not my problem, but if you are consuming like some libraries or tools that is attacked, you might be like, get some problems as well. Like people are noticing like issues like the attacks, and how that is impacting in the downstream usage of the tools and libraries. And this is getting like some problems like we saw in the market, like in the news, like some companies like reporting they got like a really bad stuff happening. And the idea is like that some regulations coming as well, like from the US government, that would like to try to improve the cybersecurity aspect of things. And this executive order, like from last year, is some first steps for that. I don't know if Adolfo, if you want to comment anything, but you can interrupt me as well. Okay, open source code is like contain like all the 98% of the code base, like based on the Sonatype report, contains any kind of open source code. And in 92% of this, that is like these tools, this stuff that is like vulnerable code or any out of date. That means like running a very old code that contains a lot of CVEs or like or other types to approach in the you can bypass some stuff. There is like links between the open source tools and organizations, like let's try to like work together and not like, okay, that's not my problem, I'm gonna consume this, I'm going to close my eyes and then continue. But this is like not the good opportunity, because this can like create a lot of issues for the inside the company that you are working for. Open source is good, right? It's open, like it's in codes free, it's transparent because you can see the code, you can read the code, you can change the code, but in reality, like not much people are like, when I'm gonna writing, let for example, create a project from scratch, I'm gonna consume a library that make my life easier, but actually most of the developers and most of the people are not like checking what that library contains, right? They are not checking like how the code is written, if there is any malicious, like sketching, like consuming data. That's not like people is not like actually checking things, like and also it's open source, anyone can contribute, but then this meme, right? How like anyone can contribute, like it's a little bit scary, because as well, like there's a lot of open pull requests and merge requests in GitLab, like people were adding code, the most sometimes can be hiding malicious code, and like if we have no way to validate those things, it's a little bit hard to understand.
Carlos, I love that slide, by the way. Some really good slides. Let's just take a pause here for a second. Chakri, I think we've got a couple questions. Not sure if this is the time for that, but if you can see the Q&A
question
box.
Is it's about certification of participation, maybe not related to this one. We can answer that.
Okay, fair enough. Okay,
you can continue, Carlos.
Okay. Okay, there's this some malicious contributors, this type squatching, like important commits. There's some examples that like that can like hiding codes. We have like we saw in the past years, like some people complaining on Twitter and other social medias. They are using some libraries, and that library was like collecting things that was not that good. Like, and that's sometimes there's like some decisions to make, right? Like use a free open source package with no maintainers that is running around that, but solves your problem, or use an expensive vendor software. And this, like sometimes you need to take a look and see what makes sense for you. Like some examples like log4shell, that all those things that happened in the past, right? It's transparent, like as mentioned before, like you can see the code, like, but actually not much people are opening the boxes and like checking how the code is written and what it actually does, right? Some issues in the past for some services, the code cover was like, I don't remember when it was, like 2 years ago, like some issues with code cover exposing data, like when you add those things to your repository, it like was doing things that were like was bad. Yeah, like there is nothing is like there is hope, like from the Star Wars stuff, like that's always a hope, and the Force is gonna be with us, but we need to work on those things, right? And then we need to see how we can improve and how like to make it a little bit better and like try to fix the problem. Yeah, like this this open source means each problem only has to be solved once. Let's try as a community, try to solve those issues and see how to make open source projects and libraries make a little bit better for everybody that's consuming.
Yeah, and I highly recommend anybody who doesn't know Knobval. He's fantastic. He's one of the top, VC startup guys here in San Francisco. So he's one of my gurus.
And a lot of good codes, right?
Yeah. Yes, exactly. I find myself quoting him and dropping his quotes all the time. And I was like, okay, I didn't realize it was sinking in, but hey guys, if anybody has any questions, feel free. Most of you can unmute yourself if you want to step in, drop a question in the Q&A. And yeah, let's keep rolling.
Okay, now we are going to talk a little bit about the signing part. Like there's a lot of projects and people like signing images, signing the binaries, the artifacts that are producing. But why signing? Like I would say, is the first initial step to become like have a more supply chain, secure supply chain. And like consumers can verify the image or the artifact it's coming from that group of people or that organization that claims that. Like this is the first thing, like we can check if that image that we are consuming is coming from a particular person that claims that owns that thing. And if you think like, let's give an example in Kubernetes, like you're deploying images, like there is some admission controller that you can deploy and configure to verify if the image that you are deploying is signed and there is a valid signing. And also you can add stuff like just allow those images to be deployed and running if it's signed by this specific set of keys, for example. Like signing the old way, like I call it old school, like it's a little bit hard. Like for me, like in Docker Hub offers this, the DCT, the Docker Content of Trust, and it's for free, you don't need to pay anything. But like the UX for that, it's like hard, and people like, it's hard to work on that. It's hard to automate those things. And if you lose a key, it's very hard, like per the Docker docs, if you lose the root key, it's really hard to recover. You need to reset you need to open a ticket on Docker Hub to then reset the repository. You need to sign everything from scratch again. And like, you need like, for Docker Hub, you need to have a notary server running that Docker Hub offers that. You need to generate a trusted key. You need to generate a delegation key. Those have like passwords. You need to store those secure. The UX on that, when you're following in the shell, is like, it's a little bit hard to understand which password belongs to which key, because they don't offer like human names. It's more like machine names. And then you need to sign the image, and then you push the image. If you do all this stuff, you have like a signed image on that. And then If you want to delegate for others, you need to run again the trustee key, you need to generate another delegation key, and then you can check. Like in my personal experience on that and doing automation on top of that was like very hard and not easy to read, and the scripts and the automation for that was not that like beauty and nice.
I agree with that.
The same
the
for
least used switches.
yeah, the same for GPG, like signing the artifacts. Usually when you sign a binary, you sign the RPMs, you sign the Debian files, or any binary do you want to sign, you use GPG, right? And like there's a lot of people in the like out there saying don't use PGP anymore, don't use these keys. And also this is not that easy, like it's not UX friendly for people. Like you need to generate a key, and those key you need to keep that, like, because you need to rotate. If you don't like set an expired date, you can like have this key running forever, like with no expiration. But if you set like a shorter expiration key, you need to do all the work, which is not it's time consuming. It's not like hard, but it's time consuming. And
so Carlos,
yes.
I have one question on this. So is this experience same for all the developers, or is it more like one person set this up and then developers kind of use it in a simple way? Is it how it is, or is it same for everyone?
Yeah, the experience I have, like one person set up all this stuff, and then this is only exists on the let's say the release pipeline, or if it's manual release, that there is one person in the company that holds the key, and they can like signing and do all the things. Of course, there is other companies, they like have those delegations key and using hardware key, then other persons can signing. Like if I'm not available, there's Adolfo can have another delegation key, they can sign that as well. But sometimes like I never saw, like I never worked in a company or saw friends of mine say, we are using GPG to sign our product, our tool, and we have like 5 persons that have those keys, they can sign. Usually I saw like they have these keys set up, and then maybe it's stored in LastPass and everybody have access to that and just fetch and clone and use those things, which maybe sometimes is not that good as well. Yeah, that I saw one comment in the chat, like if one is on vacation, then every time like when there is one person involved that set up everything, he gonna take vacations and then everything falls apart, like and everybody starts screaming, and
yeah,
this guy like gonna get like some paging, and then they're gonna come back from vacations, and then that's it.
It's actually in the SRE handbook, right? You want to test
Yeah,
the reliability of your system, send that one person out on vacation, see what happens.
This go as chaos testing.
Yeah, guys, I just wanted to say we're just getting some really positive feedback. People are saying that this is a great topic. Feel free to drop questions in the chat, or not in the chat, put them in the Q&A box if you don't mind. That would be great. Feel free to unmute yourself if you have a question. And Chakra, I'm not sure if there are any more questions to bring up at this time. Maybe in the chat there. No questions. Okay, great.
Yeah.
Okay, then let's introduce Cosign, like let's say a more friendly way to sign your images or sign your artifacts as well. Cosign is part of the sigstore organization. You can like take a look on sigstore.dev. This organization was founded last year by people from Red Hat, from Google, from VMware, and also from myself, like from Atomos. I was just contributing to the project, and I saw like some other persons here in the call that helps a lot on the sigstore project as well. And Cosign is part of this organization, and this the first step. We have other tools. We have Record and Fusio to deal with other things, but Cosign is the topic right now, and Cosign is help us to sign, verify the signatures, and also verify other things. Like you can, with Cosign, you can attach SBOMs, you can do other things as well. Cosign also, like we're gonna, in the demo, we're gonna show like 2 use cases using Cosign. But Cosign, you can generate your key, like you have a private and a public key. Also, you can use a KMS system like for HashiCorp Vault or any AWS KMS, Azure KMS, or GCP KMS, any other KMS that is available from the cloud providers. We can use to store and retrieve the keys to sign the things. Also, like if you are on Mac, and usually on Mac, because we generate the binary for the PV keys enable, you can use your UB key to have the key and use your UB key to sign the image as well. You can attach information to the signature as well, and this is the first step. Like, right, it's easier. Like for we saw before, like there's a lot of things to do. Here it's much easier, like to think about. Like we can generate a key, put in KMS, and then like in your pipeline can consume those things. Let's try a demo now. Let me reshare my screen. And I'm gonna ask if this is a good size.
Yeah, that's good.
Okay. Okay, Cosign, you can install, if you have a Mac or Linux and use Homebrew, you can install with Homebrew. Also, you can go to the GitHub repo, and then you can download the packages and the binaries from there as well. The first demo is generate the key, like, and sign an image with the key we generated. The Cosign command, like, let's take a look here. We have the latest release of Cosign, which is 1.60, and we have, let's get our help here. We have a few options, few commands that we can use. In our case right now, we're going to generate a key pair that going to have a public and a private key. This is going to ask a password. I'm going to put like a super secure password. And now we have 2 keys, the private key, which is encrypted, and the Cosign public key. Let's take a look on those things. This is encrypted by the password we typed. This is like a, of course, if you put like a very leak, like a small password with 1, 2, 3, 4, for example, which I don't say to push this to your public repo. But if you have a strong password, usually people are pushing the private key as well to the repository and make those publics as well. You don't need to store that in a environment secret. For example, if you're using GitHub Actions, you can just put those in the public repo as well. And then the Cosign pub is just the public key. Okay, I have, just let me double check I have one image pushed to the Docker Hub called the demo meetup. It's just like a very simple, I copy that from another place and then just push to my repo just to sign this. There's no signing there. Like the idea here, we're gonna just focus on signing the image. We are not focusing on how to build that image, but let's assume that our pipeline or our steps build this image here, the demo meetup, and now we are in the stage to sign the image. We generate the key. We're going to sign the image using this private key here. And the command is Cosign, sign. Then we pass the key that we want to sign that. And then the image.
Carlos,
Yes.
one thing. Can you bring up the cursor?
Oh, okay.
It's hidden in the bottom.
Yeah. Cosign. Let's Cosign, sign, key, Cosign key. And here we also can add annotations to that. Let's say, for example, I want to put a test. Can be anything you want to annotate as well. Or like, let's say, I'm just faking data here, but we can say, okay, this is gonna be my git tag v00.1, for example. And
is that a common use case, Carlos?
Usually, like we annotate the tags. We in a pipeline we put usually the git tag and the git hash together as well as an extra notation. But you can add any kind of information. You can put your name. You can do whatever you want to do. Yeah.
And how do you use that later?
Yeah, and I'm gonna check when we verify. You can see those things. Okay, then let's check again. The command is signing. We pass the key, and we just set an annotation here, which is optional. You don't need. And then we say which image we want to sign. Okay, it asks my password. I guess I forgot my password. No. Okay, it says it's signed it. Like, and if we go back here, we're gonna see our tag for the latest image, and you're gonna see this tag here, which is the signature. This signature contains the digest from the image we signed and the signature itself. The image is signed. Okay, now, yeah.
For the people who don't know, Crane, can you explain what it does? Oh,
Crane is a nice open source project that does help you to do a lot of things in the containers. Like let's take a look quickly here. For example, usually I use Crane to get the digest, to list the tags in a repository like we did here. But they have other options. For example, if I want to copy, it's out of scope, but let's look quickly. Like usually when you have one image in one repository and then you want to push to another different repository, usually I see people doing Docker pull, the image they want to pull, then Docker tag, then the image they pull, and to change to another registry, right? With Crane, we just do Crane copy from this repository to another. They do all this stuff for you. You don't need to pull and tag and retag and do things. You can just do a copy. And there's a lot of other tools, other commands that it's very handy and useful for like dealing with images. I hope that clarifies a little bit. I can put in the chat later when Adolfo is speaking the link for the GitHub project for that.
That'd be great. Thank you.
Now we sign the image. We can take a quick look here. Let's verify that image. Verify. We need to pass the key. Indeed, now the key we want to use is the public key. This key is like, for example, if you want to verify if the image I produced is valid, you need to use this key in this case to verify if the image you are checking it's valid with the key you provided.
This almost looks like TLS keys.
Yeah. And it says that the verification it's okay, it's validated, and then we can see here there's a optional set of key pair values that we set, right? The git tag and the test true we set. It also says the image is from this digest. If we, let's just do a create digest. It should match this with the signature, which means that it's attached to each other. Okay, this is like a, now if you guys want to validate if my demo meetup image is signed, I need to like publish my public key, which is sometimes right now you cannot do that. There is another approach, which is we don't generate our keys and have those as hard-coded, but we generate ephemeral certificates, and that is valid for, I guess, 5 minutes, and then we can use that to sign, and then those gonna be published together with the public certificate gonna be published together with the signature. How to do that? That is experimental right now for in Cosign. There is a feature flag we need to enable, which is Cosign experimental, and then we can do this. Let's do this. We can use just sign, and then let's sign the same image again. And it's generating ephemeral keys. I'm not sharing, just sharing my let's see if I can share everything, and then everybody can see. I hope you can see everything now. It generate ephemeral keys and then ask me to log in and like prove like to connect the dots, right? I'm gonna log in with my Google account. And then let's just stop sharing and sharing again. Now, in this case, it generates a set of ephemeral keys for me. I confirm using my Google account login. And also, like, since we are using the experimental flag, this is using another tool in sigstore, which is Fusio, which generate the ephemeral certificates for us. And also together, it's pushing the logs, the signatures and things to the record to the transparent log that is public as well. Everybody can consume those things, and it's generated here. And then it's also, yes.
One question here. So when you do experimental one and then Cosign, is it still using the keys that you generated, or is using?
No, I can, okay. Yeah, I can, let's like to be very sure that we are deleting. We don't have any keys anymore here. And I can sign my, let's do the process again. I can sign it again. And there is no key. It generates as ephemeral keys that I can use that. That's a very fully automated step. We just need to sign. We just need to open the browser and click to log in for us.
Sure. So this is going to be using your GitHub as the identity.
Yeah, that's that. I'm gonna talk about this step in the end of the demo. This is also like need human interaction, right? Because I need to open the browser, I need to log in with my GitHub or Google account, and then it gone back, generate the keys, sign, push. Now,
sure. We have one question
sure.
from Ludovic. Can the public key be stored as an artifact as well?
Yes, the keys are stored in the registry as well. Now, for example, if I try to Cosign verify my image that I signed, not passing the key, right? The Cosign command complains about like I need to pass the key reference, which was my public key that I just deleted, or I can pass my S key, which is the UB key, if I have that, use that to sign. In this case, I using ephemeral keys. Then we need to go back also and enable the experimental flag, and then I can do this, and they're gonna verify for me the signatures. What this is doing in the background, it going to the registry, getting the signatures, getting the public certificate, and then going back to the transparent log and verify if everything is there. Now we have a lot of things here because it attached the timestamps, it attached the as we can see the issuer for my certificates, and then we can see my subject here, which is my email. It's saying I signed it like this person signed the image. Since I signed it twice, I see twice signed stuff with the same. And now, like, we are not like, as you can say to me like, oh, but this is not like, it's hard to verify all those things, like just if I want to like fine grain verify, right? We are working to make this UX a little bit better. Like when you do the verify, you want to see like the subject, the issuer, the transparent log and other things. We are like working to make it a little bit better. It also have the log index here in the transparent log, which we can use another tool for sigstore, which is the record CLI, that we can fetch this log from the record for the transparent log, and then we can like also do the check. I'm gonna just quickly, because I think I'm running out of time. I can do record CLI, get log index for that index, and
Carlos, take your time. We have more than enough time.
Okay, and then it also shows to me the logs, and this contains all the information like in base 64, the public key that was used for signing to verify the image. And that is a lot. This is the other information for the data that we can get out from that.
So Carlos, one basic question. I think, what does record CLI do? There's some other question we have.
Yeah, the record CLI is like an idea like you can use to fetch the logs from the transparent log, and like it's an addition for the Cosign verify. Cosign verify also go in the background when you use the experimental flag, those checks for you. But if you want to do like your check, you can use this tool as well. And I forgot, but you can open the browser as well and pass the log ID, and then you can get the similar information as well, like from the record website.
Mm-hmm.
Okay, we signed the image like generating ephemeral keys, right? But it asked me to like sign and log in using my account. In a pipeline that automates that, like for example, on GitHub Actions, I guess GitLab as well, GitLab pipelines offer that in the last release as well. We can use OIDC tokens, and those gonna generate a token for you, and you can use that to generate the ephemeral keys for you, and you don't need to like do this manual clicking and signing. In the end of this talk, we're gonna have the demo that is using the GitHub Actions and using the OIDC tokens from GitHub to generate a token and sign that for us in a pipeline. That's the we call it the keyless approach, that we generate the keys like ephemeral keys that is valid for a specific amount of time. I guess it's less than 5 minutes, and then they expire the key, and then you cannot re-sign using that key if you manage to go get the private and the public certificates from that. It's gonna expire after, I guess, 5 minutes. Okay, thank you.
Yeah, at some point, one question.
Yes.
At some point, you'll be covering like how you enforce this verification in some kind of admission hook, or like how do you actually automate this verification?
There is another project also that it's an admission controller. It's called Cosign that can verify those things. I didn't show, but if you take a look on the tags they pushed when we sign, the certificates are there in the registry. We can retrieve that. You can get the certificate. You can use that if you want to verify your things. But with Cosign, using this approach, you don't need to extract the certificate and use that. But for example, for a binary, we can output the certificates and the signature, and then you can get those things and use to confirm the signatures as well.
Okay.
If I may add to that last answer, so just as there's the Cosine D, Cosine or whatever, this is one of those things that you never pronounce, so you're never sure how to tell it.
Sure.
But in addition to Cosine D, there's also a demo that Batuhan, or AKA developer guy who's here, at some point did about enforcing admission control to the clusters using OPA. If you check the answers, I linked the project there. So for anyone that's interested in that.
Thanks a lot.
Okay, Adolfo.
Okay, so my turn. So I'm going to speak and say next whenever to answer the slides. Okay, so supply chain security is like a complex topic. So signing takes care of a part of securing the pipeline, securing your project in the middle of a bigger chain. But it's a complex subject and it has many attack vectors. So before we go on to the next topic, I wanted to just talk a little bit about Salsa. And Salsa is a framework it has a lot of the same folks that have been working on sigstore behind it. It is a framework that allows people to incrementally secure their supply chains, and it will. And what it does is that it allows you to secure your pipeline from in incremental ways, starting with more observability of the threat vectors, and then securing it a little bit more. Oh, the next one, please. So
is it okay if I ask some questions? There's
yes, of course.
Some Q&A. Yeah. So Vladimir wants to know: is it possible to use self-signed X509 certificate instead of ephemeral certs generated by FulCO? FulCO.
Yeah. So FulCO is a project to have your own certificate authority, which emits the certificates for you. So can you have self-signed certificates to sign? I'm not sure. I don't think so. I don't know, Carlos, if you know. I don't think so, but
okay, sure.
Because Cosign will eventually go and verify your. So as Carlos said before, all of the authentication of the signing entity is done with OIDC tokens. So it will, whenever you get the authority for the authentication of the signing entity, it will Cosign. I think it will check that with Fulcio to ensure that the entity matches the tokens that it's using. But
Sure.
don't quote me on that. But I just by my understanding of how the code works, I think it's not possible. But it's an interesting.
Cool. There's another question from Juan Hernandez. Okay, it just vanished. So
I just replied there. Sorry, okay. I didn't know that you're gonna disappear.
Okay, good. Go ahead, Adolfo.
Okay, cool. Yeah, so I answered a bunch of the questions before, and so feel free to look on the answer tabs for some of the answers. Okay, so as we were saying, so whenever you think about a project, as the project goes from the actual writing of the developer to the end user, there are many places that it can be attacked. So the idea with Salsa is that it proposes several practices for people in projects to help them secure their environments. Next one, please, Carol. Next slide, please, Carlos. Okay, so well, the next one. So Salsa proposes 4 levels of hardening, which starts with first generating documentation about. Well, this is like an overview. Each of the phases has its own more explicit set of requirements. Salsa, I have to say, it's a project which is hosted under the OpenSSF, the Open Source Security Foundation. So it's still under heavy proposal and change, but there are already some good advices that projects can get from it. So the first one mainly deals about generating some information about whenever you run your project so that you can see where you're standing. Then it adds signing so that information cannot be modified. And then it also deals about hardening the environment where your build process runs. And finally, it deals with some of the more complex human aspects of trying to verify who has access, what are your practices of signing off on commits and things like that. So just worth noting that the things that we are talking about today are 2 measures that allow that try to secure some of the most evident and vulnerable places in a supply chain, but that's not all. So if you want to get like a more thorough overview of what you can do to secure your supply chains, you should go and definitely look at the Salsa levels and start trying to consider them. So Carlos and me both work on the Kubernetes project as both as release managers and also as technical leads in SIG release. And we are currently going through a KEP to harden the Kubernetes release process by following Salsa as high as we can. So some projects may not be able to achieve the higher levels. Particularly level 4 is pretty hard because it involves owning a lot of the infrastructure where your builds run, for example. But we are trying to make it as high compliant as possible. So I wanted just to touch on that subject a little bit. Okay, so the next one. So let's talk a little bit about SBOMs, software bill of materials. So
I don't know, one question.
Sure.
About Salsa, is it like more of a specification that you give, or like for end users, how is that consumed? In the sense, okay, these are the specifications and there are some tools that comply to it, or is it like more of practices that you need to do to go with level 1, 2, 3, 4?
Yeah, so each level deals with different things. Some of them are just practices around, for example, policy, and some of them also deal about technical changes that can actually produce verifiable artifacts in your builds. For example, if you run like provenance attestations of your builds, provenance attestations is a file that makes and gives absolute certainty to downstream consumers about how and when the artifact they are pulling was built. So you can actually, for example, in Kubernetes, we're trying to build provenance statements that if you consume a version of Kubernetes, we're trying to bridge all the build process all the way back so that you can actually and undeniably know who was the release manager that actually clicked the button to launch the build. And you can see on those provenance attestations all of the build parameters that went in. So what artifacts it produced, how those artifacts move from one stage of the build to another, and so that's one. But it also involves other things like signatures, for example, of your artifacts and images, and also of other internal things. So, for example, there are signatures that sign the provenance attestations that they cannot be verified. So that's one. It also deals, for example, with some recommendations, more than recommendations, are more requirements. If you want to brag that your build system is Salsa level 3 compliant, it imposes some requirements around, for example, making it air gapped so that it cannot talk to the outside world to minimize the risk of actually pulling things into your build process that you don't want to see there, for example. So it's a very comprehensive framework that gives a lot of recommendations, and the discussion around it is really healthy because lots of big companies and users of software producers are actually chiming in and sharing their experiences. So it's moving really fast, and it's becoming a very rich and all-encompassing framework.
Yeah, just a continuation on that. Like, which verticals do you think will be more benefited with this approach? And also, does it automatically solve some of the problems with the audit and then compliance that are required by some companies? Like, can they produce this report and say, yeah, we comply with these particular policies, or
yeah? So currently there's very little automation. There's some discussion around how to actually be able to automate some of the human aspects in Salsa, for example. There are some proposals that of how to digitally attest that, for example, if you want to attest that, for example, around access policies to your builds or your data center, there's a proposal floating somewhere. I don't, since I wasn't planning on going this in depth, I don't have the links at the hand, but there's a proposal, for example, to produce an attestation that a third party can audit your environment and actually attest that you do in fact comply with some of the human aspects of it. So the parts and machines cannot verify.
So thanks.
Okay. All right. So going back to the SBOM. So whenever you sign your artifacts, that will give you the guarantee, at least if you're signing them with sigstore, with the sigstore ecosystem, it will give you the guarantee that that artifact has not been modified, that artifact was in fact signed off by the person that is actually stated in the actual metadata that was signed. So if I get one of those signatures, it's going to be really, really hard for Carlos to deny that he actually signed the images in the previous demo. But if you think about it, having a signed thing doesn't really give you any visibility into what you are using, what you are pulling, what you are consuming, the artifacts that you are using. So it's the proverbial Trojan horse, right? So you simply get an artifact and it is like really well decorated. In fact, it has been signed by someone you may trust, but you don't know what's in it. So if you go back to some of the really scandalous recent vulnerabilities that were just found, like Log4j, for example, the fact that Carlos signed off on a release doesn't guarantee me that it doesn't include one of those vulnerable dependencies. So this is where SBOMs come in. So I like to do the analogy that an SBOM is like the packing slip on a box that you get. It gives you some of the metadata that you need to know about what you are consuming, and not only what you are consuming, but by yourself and your project producing SBOMs gives further down the chain the same guarantees to users downstream of what you're producing. So everybody can either accidentally or by other means include vulnerable dependencies, but I think it's a great transparency effort to let your users know what you're including in your builds. So just to do a quick overview of the SBOMs, what they help you. I'm going to go through this kind of in a faster pace. So the first one is metadata about the software itself. So where did it come from? So these are all analogies by using the same packing slip on the physical box that also apply to software, right? If you get a package delivered to you, the metadata in the packing slip will allow you to know where your box actually came from, when they shipped it, some of the customs crossings that it did. So the next one. Then it will tell you some information about what's inside of your box. So how many items do you have there? How do they look like? And also the last question in there, are things in good shape? So you can expect to have 3 things, but are they broken or not? Have someone, for example, I have a friend that deals in wine, and he tells me that a big problem in wine producing countries is that whenever you ship wine from one country to another, it sometimes gets replaced by wine that's tampered with, and you buy some wine and get another. And so in software you can avoid this kind of fraud using an SBOM. Okay, next one. So the packing slip will also tell you some metadata about the manufacturer process that built the item you're receiving. So what were the actual ingredients that went in there? You can actually grab sometimes, for example, a food item and see all of the naughty chemicals that it has in it before you eat it. So what were other products built during the same manufacturing run? So if you have like a part number and a lot number, you can trace other defective. If you get a defective item, you can use it by using the packing slip and the date in it. You can locate other components that may have the same vulnerability, right? Okay, the next one. So just give me 1 sec because I'm gonna prepare for the demo. Okay, so like I was saying, the SBOM allows you to answer some of the same questions around about your project. So it'll tell you how and by whom it was built. It'll give you some information about the dependencies, so for example, when dealing with container images, the SBOM can tell you just by looking at it, the base images it is based upon. So you can, for example, if you have a notice that a base image has a vulnerability in it, you can use SBOMs to quickly track all of those, all of your projects that are using them. Then it will allow you to answer questions around licensing. For example, if you have, for example, you have in your company a project and you wanted to release it as open source, the SBOM has all of the information about licensing in it, and it can tell you if you can actually do that. And not only that, it will actually allow you to answer the questions around what kind of licenses you're using. So are they open source or not? Are you touching more controversial licenses that you may not want your software to be touching, so that it doesn't have implications to the software or to the licensing entity, right? Okay.
So Adolfo, one question.
Yeah.
When you implement this kind of supply chain, like the SBOMs, the trust and all that, is it more like whenever you supply software, it is like trusted by end users by just looking at this? Is a trust factor important here, or do you get any other benefits when you go with this approach?
So what do you mean about the close factor?
The trust factor, like
Okay.
when you do this setup, is it like when you're distributing software, you are making it transparent for the end users? Is
Exactly.
that what is the benefits? Okay.
Right. Exactly.
Are there any other? Yeah.
So, but not so. An important thing to note is that not all companies choose to make their SBOMs public. There is currently, I think Carlos showed it in some of the first slides. There's the executive order for infrastructure security. Probably we can link it here, which in as part of the requirements, it's calling federal agencies to impose on their software projects. It actually demands, it sets a timeline for organizations to start producing SBOMs. So either not only producing, but also consuming. So all providers that supply in the US software to the government, they're going to have to provide an SBOM to the agencies that consume their services and software. So
this is more like a motivation factor, like what motivates you to implement this.
Exactly.
So,
yeah, the idea is that so most of the central most of the central interest in SBOMs has come from that, because also they want to have like a quick way of referencing and locating, so that the federal government can know as quick as possible if where the vulnerability may lie in the software that they are using. But as we've been seeing here, it provides you a lot of other benefits when you run it. Okay, so let's go to the next one. Okay, next slide, Carlos. Okay, so if we were to sum up the SBOM, what an SBOM is, it's a verifiable list of the components in your software. And the components can lie inside of can be listed inside of the document, but the rich part of the SBOM is that they are also related in one another. So you can have files, and those files can be listed as dependencies, can be listed as components, as example, as tests. We are going to see a little bit about that in a little bit. Okay, so let's go to the next one. Oh, next one. Okay, so there are two main competing standards in the SBOM world. Both of them are really good. Both have their strengths and weaknesses. So the first one is SPDX. That is a project of the Linux Foundation. SPDX is actually an ISO standard, which has been codified into an ISO standard. And there's CycloneDX, which is a project of the OWASP Foundation. I'm going to be talking mostly about SPDX because it's I maintain one of the tools that produce that, so it's easier for me to go around SPDX. So let's go to the next one. So let's talk a little bit about what an SBOM looks like and what it contains. So the first one is you have to think about the SBOM as an empty document. And that empty document is going to have all of the components that you want to list in it, but also some metadata, the data about itself. So it will give you an ID that exists in a namespace, which is unique to the document, so that it can be located in the internet, has a name, the version, who created it, what organization, and some information about the tool that actually produced it. So next one. Okay, so when you start adding so you have your empty document, and then you start adding things to it. So SPDX is structured around two main constructs, packages and files. And you can have packages which can be empty. And also you can have packages with files and other packages in it. So using those basic constructs and the relationships around them, you can express really complex software releases and artifacts. We're going to see some examples around them in a little bit. So you can also list at the top of the document files straight up at the top. Okay, next one. And this is a part of the relation where the relationships come into play. So all of the items that you list inside of the document are related between each other by a set of fixed relationships defined by the SPDX standard. So you in this example here, you can see that, for example, the outside file number 1 is marked inside of the SBOM as being a test of file number 3. And then you can see, for example, that package number 2 was generated by package number 1, which can possibly be its source code, for example, or a tarball. Okay, next one. And this is a little bit of how the actual SPDX code looks like. That one is a piece of the Istio SBOM, which I helped produce a little bit like last month, helping out the contributors there that took on the SBOM project. And so if you can see some of the things that it lists there is so the SBOM is much longer than we can see here, but some of the things that you can see there is that it defines a topmost package, which is named Istio. It has some of the licensing information. It has, and then below it has one of the source file, which is it's basically the first file in the repository. The file has some information about it, and also licensing information and other things. We're going to talk a little bit more in depth in the next ones. Okay, so next one. Okay, so this is what I was talking about. Whenever you list a file in the SBOM, it lists some of its information, the file name, the type, some checksums to ensure the integrity of the file, the licensing information. You can actually cram the whole license into the SBOM if you want to, so that people can refer to it, or you can simply specify like an identifier, which goes back to a catalog defined by the Linux Foundation of licenses, and has some of the contributor data, like who is supplying, who is maintaining the package, and so on. You can also add notes to it. Next one. And same for package. Each package can have a name, a version, a file name. Not all of these apply all the time. For example, if you conceptualize a container layer as a package in an SBOM, file name doesn't really apply to it, but you can express it in some way if you want. The originator, so where can you download the package, and all of the licensing information. Okay, and the next one, this is like a word cloud I did about using all of the SPDX relationships. You can see that there are many cases. Probably some are hard to use, but there are some basic ones like dependency of, so you can tag a package being a software project being a dependency of another, things like that. So using files, packages, and the relationships, you can create like a really complex SBOM. Next one. So this could be a way of describing a complete release. So if we have, for example, this could be a release that is broken down into 3 SBOMs. One for the source, one SBOM describing the source code, one package for the source code of the project, one package for all of its dependencies. Then in the middle we have an SBOM describing the binaries and packages of that set project, and then we could structure the container images in a separate SBOM. If you see there, I kind of try to express that you can have a container image. You can have, for example, if you think about a multi-arch image that provides, for example, 4 architectures behind the same tag, you can express all of that inside of the SBOM. We're going to see an example about that in a little bit. And then you can see some basic relationships I added there just to express that the artifacts in the middle and the container images are generated from what could be potentially source code SBOM. Okay.
Just one question on this.
Yeah.
So how much of these relationships are automatically generated, and how much it is manual?
Good question. So it, of course, depends on the tools that you use, right? You can craft that SBOM by hand if you want, but there are some automated tools like we're going to see just now that will help you do that. One thing to note around the SBOM landscape is that my appreciation of it, I'm fairly involved into the SBOM tooling circles because I maintain one of them. And one appreciation that I've been seeing is that there are like silos of SBOM practices that correspond to different industries in software. So we in Cloud Native are building our SBOMs in one way. But if you go to, for example, embedded systems, they are doing things using the same language, different practices. So, and even within one industry, it is sometimes hard to make the output and input of the different tools match between each other because it's so new and it's moving like really fast. But we're working on that. And so one of the things that I do at work, for example, is trying to do just that. So to match and trying to make tools talk to each other when using and consuming SBOMs. Okay, so next one. Let's try to do the SBOM demo. Let me try to share my terminal.
I just want to say I am impressed for those who are still hanging on. We've got a dedicated crew.
Yeah, thank you so much.
It's good stuff. Getting a lot of positive feedback on this topic.
Okay, let me share my terminal. Okay, can you see it? Maybe it's a good size for.
Yeah, you're good.
Yeah.
Okay, cool. So I'm going to be doing some of these demos right at the head of a branch that I was working just yesterday because I really want to show you some cool stuff that I've been working. So I am one of the maintainers along with the Kubernetes release engineering team of the Kubernetes SBOM tool, which so the story of this tool is that when Kubernetes decided that it needed an SBOM, like 1 year or year and a half back, we developed some code to produce the SBOM, and we thought that, well, it was too much effort just for Kubernetes, so we actually distilled all of that into a public tool which people can download and use, and it has some features that I want to show you. So the tool is called BOM, just like that, and it supports a couple of modes of operation. So the first one is, well, the two main ones are that it will allow you to generate and also work with SBOM documents. And so the first one we're going to be using is generate. So to demonstrate it, I'm going to do an SBOM of the Nginx image. So so BOM will allow you to consume to describe artifacts, several kinds of artifacts. It allows you to describe Go repositories, because this is Cloud Native. So it will give you a good amount of detail about your Go projects. We don't have support for other languages yet. If anyone is interested in working on that, I'm happy to talk. But it can scan your Go repositories and give you information about the dependencies. It can read tarballs, it can read container images, either archived on disk and also on the registry. It can also add individual files, and I think those are it. So what I'm going to do right now, it's just pass it an image reference, which is the official Nginx image from localhost, and I'm going to generate an SBOM describing what it can find there. So I'm going to give a brief overview of what it's doing. So first, BOM connects to the registry. It will pull the manifest, and it will find that it's a multi-arch image, which we can see here. So these are all the architectures it found for Nginx, and then it's right now what it's doing. It's pulling each of the layers to do some analysis about and look inside of them to see what it finds. So it's right now it's extracting the images, and it's trying to see what describing each of the images, taking snapshots and hashes of each of the layers, and it's done. So also using BOM, I can take a look at so if I take a look at the document that was just produced, you'll see that it's the same kind of tag value code that we just saw. So we have a package describing each of the layers, and it has some information about what it found inside. But if you see this kind of code, it's really hard for people to look at and understand, also to conceptualize. So you don't have an idea of the packages and the files that it found inside. So BOM allows you to take a look at the actual document that was produced. So you can do an outline. Let's give it one. So let's try to go layer by layer of the document to see what it contains. So this is the topmost. So it produced a document which is named that UUID, because I didn't pass it a name, so it generated one. And that one has one package, one topmost package here, which is the topmost Nginx manifest layer. So this is the digest for the manifest, and it lists here that package has 6 relationships defined. So if you pay a little bit of attention of what I was saying when I started running the tool, those 6 relationships are the actual. So we have at the very topmost the image manifest, and then that manifest points to each of the 6 architecture images inside of the registry. So I will now pass it more depth and inspect deeper into the document so we can see. So this one, so let me see. Let me see what I can.
Hey, Adolfo, we have about 5 more minutes.
Oh, okay. So I'm gonna rush through this one.
I'm impressed. I think the amount of new information has been really, really impressive. And I think you guys have set a record for the most demos in one meetup. So that's great.
Okay, just let me rush through this one and just so that you can see all the information that's in there. So you have the topmost document, and then Nginx, the topmost Nginx package contains packages for each of the images inside of the same tag, like that. So if I go one level deeper, it will give me information about each of the layers in those packages, like that. So I have the Linux Nginx for ARM image. It has one layer, one layer, one layer, one layer, one layer. And all of these are marked as variants of the topmost package here. Then if I go one more deeper, it will actually tell me information inside of the actual Debian base images that we're using here. So we have the Nginx for IBM S390X platform, and then all of this is so this is a Debian image, and this is a second, the topmost Debian image that BOM found, and it gives me all of the information about those packages, and you can have the information there, and you can also use it. The SBOM also contains information about using package URLs in the inside of the SBOM, and it can, so you can use these package URLs to link up to other tools like security things and so on. So I'm not sure if we want to go deeper on this one. Maybe we can try the pipeline, or maybe answer questions. I don't know what's best.
Yeah, I think we gotta start wrapping it up. So
Okay.
Yeah, just go ahead and finish your thought there if you have an additional thought. And yeah, so the lines are open if you want to ask some last minute questions.
Well, yeah. So just to wrap this up, we had a demo of tying all of these together in a pipeline. Maybe you can trust us that it works, and or maybe you want to run it, Carlos?
I just post in the chat the project, and then like I don't think if we can go over that, but people can take a look on the workflow and see how it works.
Exactly,
Yeah.
and yeah, the workflow has basically the way it works is that it will produce a simple image when tagging a repository, and it will publish that, build the SBOM, and be done with it. So maybe I hope this wasn't too much or overwhelming. But
it's definitely useful. Pretty good one.
It's a crash course for sure, which is great, Adolfo. This has been fantastic. Question. So a lot of people always ask, how do we get involved in these different projects? You've covered a lot today. Any suggestions or kind of pointers?
Okay, yeah. So for sigstore, there's a community call that happens every Tuesday at around so it's like, I suppose, 11 Central time. And there's also before that we have the Kubernetes release engineering call where we discuss around the effort to secure the Kubernetes pipeline, and that's also a good place to ask about the Kubernetes SBOM tool that we just saw, and also we can we're going to leave links on the presentation that's going to be shared, and be sure to find us on Twitter mostly, at least for me. I don't know, Carlos, if you prefer another way. And we're also active on Kubernetes and on the sigstore Slacks. Also sometimes on the OpenSSF Slack, you may be able to find us there. And yeah, happy to answer any questions and continue the conversation.
Yeah, I just adding a little bit, if you want to contribute to like any project that we discuss here, just maybe show up in one of the community calls and get involved with.
Fantastic. And it looks like Engine, I'm sorry if I'm mispronouncing your name, but do you have a question there? You have your hand raised?
Yes, of course. I would like to ask a question, if it's okay.
Yeah, yep. Go for it.
Okay. Thanks, first of all, Carlos and Adolfo, for the great session. I've just one idea in my mind, because I'm coming from an enterprise backend, so you can imagine that we are not really on the cutting edge. So it has to be something where we say, okay, that makes sense also on a large scale with different characters inside a larger enterprise, from hardcore good developers to the normal everyday developer. For me at the moment, the problem is, or not a problem, but the question is, will there be in the future a more developer or UX friendly version to say everything is nicely built? But because currently, as you see, you need to go here, you need to check out another program, you need to keep in mind to execute the generation with following commands. So will there be something provided from chain guard to say, okay, there's a solution, all-in-one solution where you could just install, for example, something and say, okay, now it's activated. I hope it makes sense, Carlos and Adolfo.
Yeah. Like we are working on that, but like I would say, stay tuned on the announcements. Like I think if you saw the Dan's Twitter, Dan Lawrence, which our CEO, he posted this week, like maybe next week, we're gonna have some announcements of the work we are doing internally that we're gonna like somehow start like solving the problem you have in the enterprise side.
Okay, that's perfect. I think about something like SonarCube or Snookos, you know, some kind of single point where you can look up your stuff, you can submit your stuff, and you get also the correlation as you saw everything graphically and so on. But that looks interesting what you told them. I will keep an eye on Dan's announcements. Thanks.
No problem. Thank you.
That's great. Good question. Okay, let's wrap this up. Do you want me to do it, Chakri? Do you have any last thoughts? First of all, I just want to thank everybody. It's great to see familiar faces. And Adolfo, thank you so much for this and putting this together. It's been content rich, and it's definitely the kind of things that our audience likes to get exposed to. Carlos, thank you. Great presentation, great talk. Our next event, can you see this next event that we have, Scaling Observability? Are you able to, you're able to see that? Okay, that's our next event. I dropped a link in earlier, so join us for that. We might even add a fourth person on there, but this is going to be a panel discussion. So I don't know, we've had Joe speak to us before. He's fantastic. He's a really, really good speaker for those of you who haven't seen him present. Natalie is amazing as well. So, and Frederick. So I think you guys will be good with that. What else? I did want to share for fun for the 10 people who are still here. So we have a sponsor for the community. So Inbound, and these are the founding team is the creator of Crossplane, will be supporting our community and it's going to be one of the sponsors. So I just wanted to share that with you. More to come. And without further ado, we'll wrap it up. Thank you, Carlos, Adolfo, Chakri. We'll see you at the next one. Take care.
Thank you for having us. It's been very fun.
You're very welcome. We'll talk soon. We'll be in touch.
Awesome.
Okay, take care. Bye.